Hello, let's continue second lecture. In the previous lecture or the first video of second lecture, I introduced measurement standards, and measurement standards are nothing but the standard established for various physical quantities such as length, mass, temperature, density, etc. In our syllabus, we have only length as a physical quantity, and hence from this video, we will start talking about measurement standards used for length. In the previous video, I mentioned that there are two standards used for length, line standard and end standard. In this video, I will talk about line standard only. In the next video, I will talk about end standard. I also explained that line standard means that length is recognized as a distance between two parallel lines engraved on the surface of a polished metal bar. Okay, or it's not necessarily made up of metal, it might be wooden, it might be plastic, but uh, generally I can say that whenever we are talking about length standard, the length is recognized as a distance between two parallel lines engraved on the surface of an object like scale or ruler that you use, or vernier caliper. Okay, so those are the instruments based on line standard. In line standard, there are two categories: material standard and wavelength standard. Material standard means that a physical object is used on which two lines are engraved. So material standard is a physical standard and wavelength standard is a non-physical standard. The material standard is generally in the form of a physical object such as bar, like that. So on this bar, there are several lines engraved, and if we want to measure the length of an object, for example, the length of the top of a surface, then we use this metal bar, and then we measure the length as a distance between the two parallel lines engraved on that physical on this metal bar, and naturally there will be values written, numerical values written. Then the second type of standard, line standard, is wavelength standard, and this is not in the form of a physical object because there are several disadvantages associated with the material standard. We will see them later on. But the wavelength standard is recognized as the wavelength of a monochromatic light. Okay, so if this is the wave of a monochromatic light, then the wavelength of this wave is recognized as the length, or can be recognized as a measurement standard for length. So first one is material standard. Several attempts were made for establishing material standard for measuring length, and this is the first example of line standard, which is yard. To establish line standard using a physical object, in the yard there is a bar, a bar which is made up of bronze consisting of 82% copper, 13% tin and 5% zinc, and it is made up of 1 inch square cross section, and its length is 38 inches long. The top view and front view of that bar is presented in this image. The bar has a half-inch diameter and a half-inch deep hole. So the diameter of this bar is half-inch, and there is a half-inch deep hole. So here is the half-inch deep hole. So this is the half-inch deep hole at both the ends of the bar, and inside this hole There is a gold plug fitted with 1/10 inch diameter. Okay, so you can see these circles here. Let me use another color. You can see the circles here. So those are the gold plugs inserted. The highly polished top surfaces of these gold plugs contain three transversely and two longitudinally engraved lines lying on the neutral axis of the bronze bar. Okay, so on the surface is zoomed. The surface of the gold plug is zoomed in this image. So there are three transverse lines and two longitudinally engraved lines. Okay, and these gold plugs lie on the neutral axis of the bar, because from the strength of materials we know that on the neutral axis there is no stress. Okay, so that's why these gold plugs are placed on the neutral axis of this bar. Okay, so on both the side these gold plugs are inserted. So the distance between the center lines, the middle line, so this line, the middle line on left end and middle line on right end is recognized as 1 yard. And this bar is kept at a temperature of 62 °F. So rise is defined as distance between two central transverse lines engraved on the gold plug, which is maintained at a temperature of 62 °F. Okay, so this is another image. Then another line standard established for recognized length was meter. The first standard was yard. Later on, meter replaced the yard standard. Meter is recognized as, so 1 meter distance is recognized as the distance between the center portions of two lines engraved on the polished surface of a bar of pure platinum iridium alloy consisting of 90% platinum and 10% iridium. It is inoxidizable and can have good polished surface required for ruling good quality of lines. This bar is maintained at a temperature of 0 °C under normal atmospheric pressure, and it is supported by two rollers of at least 1 centimeter diameter symmetrically situated in the same horizontal plane at a distance of 751 mm so as to give minimum deflection. So this is the cross section of this bar. So, and this cross section is such that the lines or the surface on which the lines are engraved lies at the neutral axis of the bar or of the cross section, and again we know that at neutral axis there is no stress. So these are the disadvantages of material standards, as they are in the form of a physical object. They are affected by the surrounding temperature, pressure and humidity. As you might be aware of coefficient of thermal expansion, with the change in temperature the metals change their length. Their preservation is difficult and expensive because of the environmental conditions to be maintained. Then replicas of material standards are not available at other places. They cannot be easily reproduced, and comparison and size of gauges pose considerable difficulty. So we will talk about this last point later on, but I think the first four disadvantages are quite obvious. Because of the disadvantages associated with the material standard, people were looking for a standard for length which is independent or unaffected by the environmental conditions such as temperature, pressure, humidity, and also they were looking for a standard that can be reproduced exactly every time it is reproduced. So this is the national standard. Wavelength standard is a national standard and it is invariable unit of length. Moreover, it is not needed to preserve this standard because it is not a physical standard. So there is no physical object which represents this standard, but it is basically a wave of a monochromatic light which can be reproduced whenever needed, and hence there was no need to preserve this standard. Scientists found that krypton 86 is the most stable element, and hence they decided to use its radiation for the lens standard. It was used in hot cathode discharge lamp, which was maintained at temperature of 68 degree Kelvin, and they used the orange radiation in vacuum of the krypton 86 radiation, and then a relationship between 1 meter and the wavelength of the orange radiation of krypton 86 was established, which was found to be 1 meter is equals to this constant uh, term times the wavelength of the radiation of krypton 86. So the scale is an example of line standard, as we have defined line standard as the distance between the parallel lines engraved on the surface of a bar. And you have this measuring instrument, you have used this several times, so you are familiar with this measuring instrument. So let's see what are the characteristics of line standard. The measurements taken by using a measuring instrument based upon line standard is quick and easy, but it has pure accuracy because the engraved lines possess thicknesses. Okay, as you can see in the picture or even the scale that you have, each line on the scale has a thickness, and that's why the accuracy is compromised. The markings are not subjected to wear, but the leadings end are. So that's why generally there is an additional length given towards the ends, because these ends these ends are subjected to wear and tear. However, the marking on the scale is not subjected to wear and tear. No built-in datum available, so there is no physical datum available that represents the zero axis exactly on the scale or on the measuring instruments built based on line standard. The readings taken from the measurements that follow line standard are subject to parallax error. Sometimes magnifying lens or microscope might be required for close tolerance length measurements. So these are the characteristics of the line standard. In the next video, I will talk about end standard. So see you in the next video.